school student teacher, Miss Isabel, noticed that at the start of the lesson, her students were not always paying attention. However, she has a little bit surprise for her students since it's their last meeting. Do you know what that is? Come on, let's figure it out.
Good morning, class. I hope you are all doing great today. Why am I not hearing any response? It's always like this. Come on, guys. This is our last meeting. Listen up, okay? Are you guys still sleeping?
Good morning po, ma'am. Just a little bit po. Sorry po for responding late. It won't happen again po.
Good morning po, ma'am. Same as you po.
Okay, thank you for responding. How about the others? Are Yumi and Maui the only students here? You know what, mga person? I really get why some or maybe all of you are still half asleep. But please, wake yourselves up, okay? Go, drink some water, stay hydrated mga nakshis. Or do some push-ups for the healthy living tayo ngayon, di ba?
Good morning po, ma'am. Sorry po for responding late. I get distracted by the sun's light po kasi kanina. It's blinding, just like my beauty. Blinding beauty. Oh, sino ka dyan?
Taray, pack na pack ang energy and I cannot disagree with that, Avery. How about you, Bella? I haven't heard you for a while.
Good morning po, ma'am. I'm hanging in there naman po, pero I'm about to give up on this subject.
Taray, humble ang person. How about us naman po?
Yes, I don't think so. Bella aced every activity, and as for the rest of the class, I didn't see any failing scores. And speaking of that, our problem here is your participation in class. All of you rarely answer, but at the same time excel in writing. You guys are not that attentive in this class also. I hope na all of you will participate in the discussion because I won't be the one teaching today. So, at the end of this lesson, I want all of you to emphasize the importance of this topic that someone will be discussing for today in the real world. Okay, that's all for the chika. Do you guys agree with me? Wait for a minute. I have to call her. She is not in this meeting room yet.
Yes po.
Good morning once again. Unfortunately, she has some urgent matters to attend to. Instead of that, I'm gonna pick out a student to present this lesson. I'm pretty sure you guys already know this topic. This is already discussed in lower grade levels. Therefore, this will only serve as a review, okay? Huh?
Oh no! Who's the unlucky student who will act as a teacher? Will they do a good job? Will the teacher get what she wants from her students? Will they have an unforgettable last day as a class?
Right. The fourth person on my screen is the chosen one. And that is Miss Samantha. I don't want any excuses. If you did a good job at the end, Sam, I will not give the final examination to all of you. On the other hand, if you decline, you'll have to face consequences, such as getting a 0 on your performance stats. So, you choose.
Oh, shucks. Please save us from hell.
Gusto mo na ba i-claim yung 5K?
Nice one, Maui. Anyway, please say yes.
Hay nako, enough of that. Yes or no?
Fine, but don't come after me if I won't do a great job at it. Just kidding. I don't want to. Mom, can't Bella just do it po? I'm pretty sure she'll be naturally good at it.
Your fate is already decided, though.
Just do it. Can't you at least try? Yes, the statistician sent the presentation to me.
Okay then, let's start the discussion.
Well, Samantha, the statistician. Oh my god, that was Leaf of Town. Yes, you heard it right. Samantha, the one that was chosen to discuss their topic, is a statistician. She is currently conducting research, and in order to lessen the probability of errors, She herself needs to experience it. The only person who knew her identity from the start aside from her was the principal. She was also the one who was invited by the teacher. And I guess she's really good at hiding it. The question is, at the end of the presentation, will she finally reveal her true identity?
The topic that we are about to start discussing is all about random variables and probability in the real world. In lesson 1.1, it contains random variables. So what is a random variable? Let me read its meaning. And I'm also really sorry about the background noise if you hear some. So anyway, a random variable is a rule that assigns a numerical value to each outcome in a sample space, or it can be defined as a variable whose value is unknown or a function that gives numerical values to each of an experiment's outcome. In short, random variable is a variable whose possible values are determined by chance. If you are not so familiar with the term sample space, that is basically the sets of all possible outcomes that can occur. So next, a random variable is typically represented by an uppercase letter, usually X, while its corresponding lowercase letter indicates X is used to represent one of its values. Why do you think so? Well, we use a capital letter like X or Y to avoid confusion with the algebra type of variable. The example given here is a coin is tossed 3 times. Let X be the random variable representing the number of heads that can occur. What are the values of random variable X? To do this, let us first create a tree diagram. You can see that on the left side of this slide. Let H represent heads while T represent tails. So this is how it looks like. When we flip the first coin, we have 2 possibilities. It's either heads or tails. If we get the heads on the first flip, we can also get 2 possibilities on the second flip, heads or tails again. Likewise, if we got the tails during the first flip, we can also get heads or tails on the second flip. That is also how it is done in the third flip. You just need to repeat the process each part. After doing so, combining them is the next thing to do. For example, HHH. What you now see on the right is the sample space which contains all the possible outcomes. Then we should finally now count the number of heads per outcome. You can see that on the image present on the right part. Thus, as you can see on the picture, the possible values of the random variable X are 0, 1, 2, and 3. I hope you understood what I have just said. Let us now proceed on the next part of the discussion. 2 types of random variable. There are actually 2 types of random variables, and these are called discrete random variable and continuous random variable. In a discrete random variable, it can only take a finite or countable number of distinct values. Distinct values mean values that are exact and can be represented by non-negative whole numbers, while a continuous random variable can assume that infinite number of values in an interval between 2 specific values. This means that they can assume values that can be represented not only by non-negative whole numbers but also by fractions and decimals. There are 4 examples here. Who wants to answer those? By the way, when you want to answer, please state your name first so you can be recognized. Let's start with item number 1, number of customers in a restaurant.
Avery po.
Okay, Avery.
I think the correct answer po is discrete random variable.
Let's see if her answer is correct. That's right. How about in item number 2, which is the weight of the customers?
Bella po, ma'am.
Proceed, Bella.
Discrete random variable po.
Is Belle's answer correct? Let's see. That's right. In the third item, measurement of a cheerleader's waist in centimeter.
Maui po.
Okay, Maui.
Continuous random variable po.
Let's see if her answer is right. Okay, very good. And then the last item, which is the item sold in an auction.
Yumi po. I think the answer is discrete random variable po.
Let's see if her answer is right. There we go, it's right. So let's now proceed to the discrete probability distribution. A distribution cannot be classified as a discrete probability distribution unless the conditions listed below are met. A discrete random variable's probability for each value ranges from 0 to 1 inclusive. Second, all probabilities added together must be equal to 1. A discrete probability distribution is a list of all possible values of a discrete random variable along with their corresponding probabilities. The discrete probability distribution can be displayed as a table, graph, or formula. In this example, the spinner is divided into 10 sections. Let X be the score where the arrow at the fair will stop. It is numbered as 1, 2, and 3 in the drawing. Find the probability that the arrow will stop at 1, 2, or 3. In P of 1, you have to count the probabilities of the outcome over the total of the outcome. You can see it in the spinner that there are 3 na 1 ang laman. So 3 over 10 is the probability of the arrow at the fair that will stop at 1. You can convert it to decimal points or percentile, and that's also how you will find out the probability of the arrow stopping at 2 and 3. As you can see, the values are ranging from 0 to 1, so the first condition is met for it to be totally considered as discrete probability distribution. The second condition must also be satisfied, so you have to add all the values of P of 1, 2, and 3, and that equals to 1. Therefore, the example given is a discrete probability distribution. A discrete probability distribution can be graphed to form a probability histogram. The values of the discrete random variable x are set on the graph's horizontal axis and the probabilities on the vertical axis. The values of x are placed in the center of each bar when constructing a histogram. The probabilities serve as the height of the bar. In this another example, a discrete random variable x is given by your teacher has the following probability distribution. Determine P of 3 and construct the probability histogram. In order to find the value of P of 3, add all the values that are given first. The sum of it is 0.84. Then subtract 0.84 to both sides of the equation. And that results to 1 minus 0.84 P of 3. The answer to that is 0.16, and that is now the value of P of 3. The probability histogram of those values can be seen on the left part of this slide. The construction of it is the correct way.
Bella po, ma'am. Mass function of a discrete random variable. The probability of each particular value of a random variable is described by a probability distribution. The probability mass function, or PMF, refers to discrete random variables probability distribution. The PMF of x is represented by f of x, and it meets the following fundamental conditions. The first property of PMF is the f of x is greater than or equal to 0. And the other one, the sum of all probabilities for all possible x values in the support S must be equal to 1. So in symbol, the summation of f of x is equal to positive 1. Remember that mass points are the values of the discrete random variable x when f of x is greater than 0. the set of values that a random variable can have is known as the support S. There are infinitely many possible values for it. This implies that the set of natural numbers and the elements of S can be compared one-to-one.
Maui po. Show that f of x is a probability mass function. F of x is equal to 1 over 15 times x if x is an element of S. F of x is equal to 0 otherwise. S contains the elements 1, 2, 3, 4, and 5. Solution. Step 1. Show that f of x is greater than or equal to 0. F of 1 is equal to 1 over 15 times 1. 1 over 15 times 1 is equal to 1 over 15, and it is greater than 0. F of 2 is equal to 1 over 15 times 2. 1 over 15 times 2 is equal to 2 over 15, and 2 over 15 is greater than 0. F of 3 is equal to 1 over 15 times 3, and 1 over 15 times 3 is equal to 3 over 15, and 3 over 15 is greater than 0. 4 of 15 is equal to 1 over 15 times 4, and 1 over 15 times 4 is equal to 4 over 15, and 4 over 15 is greater than 0. 4 of 5 is equal to 1 over 15 times 5. 1 over 15 times 5 is equal to 5 over 15, and 5 over 15 is greater than 0. Step 2. Sigma f of x is equal to 1. Sigma f of x is equal to 1 over 15 plus 2 over 15 plus 3 over 15 plus 4 over 15 plus 5 over 15. If you add this together, the sum is 1. The second property is satisfied. Since the two basic properties are satisfied, then f of x is a probability mass function.
Yumi po. Expected value of a discrete random variable, the weighted average of the elements x in the support S, where each element is weighted by its respective probability, is equal to the expected value of a discrete random variable x, denoted by E of x. Use the following equation. E of x is equals to the summation of x times the f of x.
So we can see in this table that x is present, which represent the number that are approved. We have 0, 1, and 2. For p of x, we have 0.16 for 0, 0.48 for 1, and 0.36 for 2. So for us to get the expected value of a discrete random variable, we can use the formula E of x equals to summation of x, p of x. To make it easy for us to solve, we can simply just multiply the value of x from p of x and then add the product, so we can now have the answer, which is E of x equals to 1.2.
Mean of a discrete random variable. The expected value of a discrete random variable x is also known as its mean. It is the weighted average of all possible values for the random variable x in the long run. The discrete random variable x assumes values or outcomes with corresponding probabilities in each trial of an experiment. The expected value of x is the average of the outcomes that would be obtained if the trials were repeated indefinitely. E of x represents the expected value of x. The following formula is used to compute the mean or expected value of a discrete random variable x. Mu is equals to the summation of x times the p of x, where the big X is a discrete random variable, while the small letter x is equals to the outcome or value of the random variable, and the p of x is equals to the probability of the outcome x.
Bella po, ma'am. A manufacturer produces beauty products every 2 months. A random variable x represents the number of defective products that are produced in a month. The probability distribution of x is shown below. To get the mean, we have to use the formula E of x is equal to the summation of x times the P of x. So by that, we have to multiply x to P of x. 0 times 0.25, 1 times 0.50, 2 times 0.25. So the answer is 1. Therefore, the expected number of defective products that are produced in a month is 1.
Variance and standard deviation of a discrete random variable. Sigma squared denotes the variance of a discrete random variable x. It can also be written as var of x. A discrete random variable's variance is the expected value of the square of the difference between the random variable's assumed value and the mean. The variance of x is sigma square equals var of x equals summation of x minus mu to p of x, where x is the outcome, mu is the population mean, p of x is the probability of the outcome. The greater the variance, the farther the values of x deviate from the mean. The variance is difficult to interpret because it employs the square of x, unit of measurement. The value of the standard deviation is easier to interpret since it uses the same unit of measurement as x. The standard deviation of a discrete random variable x is represented by, it is the square root of the variance. The standard deviation is calculated as follows. Sigma equals square root of the variance.
The given values of x in this example are 0, 1, and 2, while the probability of the outcome is 0.05, 0.13, and 0.31. Multiply x and p of x. For example, 0 times 0.05 equals to 0. After getting their values, add it up and that will be the mean. The mean is 0.75. In x minus mu, get the value of x and the mean. For example, 0 minus 0.75 and the answer will be negative 0.75. When you got the answer, raise it to 2. Negative 0.75 squared is equal to 0.5625. Then at the last column, the value in the x minus mu squared will be multiplied by p of x. 0.5625 times 0.05 is 0.0281. The process will be repeated to the other values of x, which is 1 and 2. To get the variance, add all the numbers you got from multiplying x minus mu squared by the p of x. And the answer is 0.0833. While in the standard deviation, you only have to get the square root of the variance and that will be 0.2886. Oh, this is really the end of this presentation. Thank you so much for listening. Have a great day ahead. That's it! Finally! Woo!
Oh my, that was a job well done. So no one's gonna fail this semester, huh? Congratulations, guys.
Thank God, you're a great saver, Sam.
Gusto mo na ba i-claim yung 5K?
Shut up, Maui!
May hidden talent pala ang person. Pwede mo nang palitan si mom, girl.
Agree. You can now leave the meeting room, ma'am. Charot.
Alexa, play Traitor by Olivia Rodrigo.
Wow naman, rich si ma'am.
Kidding aside, I have something to tell.
OMG ka, do you have a question here?
Hear me out, will you? I'm actually a statistician and I'm currently conducting a research.
What the... Can I say the word pa?
No, that is a prohibited rule in this class, okay?
And I'm actually how can I say this? Actually, I'm years ahead of you. Di lang halata. Hi. I also wanna say I'm sorry for not telling this earlier. I can't just really find the right time.
Are you also the one who declined to teach us?
Yeah, but I guess not anymore because I just finished it. Duh.
Can you tell me the probability of having a classmate who turns out to be undercover?
Overreacting again, Maui. Ano to, action movie? Kaloka ka, girl?
So, my real name is actually Athena Cruz. Tina for short. Before we part ways, let me say some words of wisdom. Charot. I'm really grateful sa inyo. Thank you for building memories with me. I just wanted to say something someone has told me years ago. Free yourself from the rigid conduct of tradition and open yourself to the new forms of probability. Many of you might have already resented math due to different reasons. But what's the possibility of having a problem that has a solution every time? Only happens in mathematics, right? Can you tell me what's the use of it in a real-life scenario?
May I po? Random variables are most frequently used in probability and statistics, where they are used to quantify the results of random events.
Addition to what Bella said, in real-life events, to calculate the likelihood that a negative event will occur, risk analysts use random variables.
Also, in order to obtain estimates of the chances that specific event will occur or to determine the variability of occurrence, probability distributions are useful for predictions.
In addition to what they've said po, they are typical technique to explain and perhaps forecast the probability of an event occurring, especially when it comes to our environment.
How come you guys actively participate in her discussion? I feel betrayed. Ouch, my feelings are hurt. And I hate my job.
Mom!
Cherish! I'm just fooling around, guys. Hehe. That's it. We're done for today, and this has been really a long day with things that happened. You're really good at blending, Samantha. Job well done. Let's now part ways. Thank you for this semester, guys. Hope you enjoy your vacation. And goodbye.
Wait. Is it possible that I'll be your advisor next school year?
What?
Well, do you think there's a probability of it occurring?